to send your messages through. We would say the basic part of this is a relay. So if you just run a relay, it's awesome. So the relay nodes provide basically the bandwidth and the resources for the network to be able to distribute the messages, to be able to, for the message to find its path, the route through the network, and then also to be able to, sorry, I was going to say something and I forgot. Anyway, but then there are also other protocols than relay, which are focused on the resource-restricted devices, I keep saying that, which allow those to just connect to the network and get the information or post the information without actually being a relay node. So by being a relay node and enabling those additional services, you are actually helping the network more and enabling various other use cases that were not really possible with other implementations of messaging for Web3 because one was not focused on all these devices. So you can see the scale, like something running somewhere in the cloud, something running at home permanently, something running at home not so permanently, and then phone. Yeah, let's forget about phones. Anyway, so currently, if you want to be a node operator, it's completely permissionless. You just start a node, which you will learn in the second part of this presentation presented by my colleague Alvaro. I hope you all brought some device, or at least there is something somewhere that you can connect to. So it's completely permissionless. You just connect, you subscribe to a topic, and you start relaying messages, and then you are part of the network, and we love you. We love you even without that, but yeah. There is no incentivization currently, but we are heavily thinking about what we can do to convince people to run the node, not only for altruistic reasons, but also from the perspective of giving something back to the community that runs the node. And we are heavily working on the topics of making sure that you will not be over-consuming bandwidth or doing stuff that is unnecessary. So basically, like and protecting your own hardware. So we are working on DOS protection a lot. There is a whole topic that we can talk about. Rayman, another colleague from the team, would tell you, I can explain it to you. It's just going to take like 3 hours. It's okay. It's easy. Yeah, so there's another very important part of what the node operators care about. Then there is the second part of the story, and that's I want to build something on top of Waku. I just don't want to help the network, but I want to build something of my own. And to do that, there are multiple SDKs, software development kits, that allow developers to build the application. So JS Waku mostly focus again on the browser. So if you have your dApp with your amazing DeFi protocol and you want to allow people to message each other, or if you want to allow your various clients connect to each other and exchange some state or something, you can use JS Waku from the browser. You can use Go Waku, you can use NVaku, Nim Waku to build something if you like Nim. Like I do like it very much. I'm supposed not to lie, but yeah, anyway. And there are bindings, so there are Rust bindings currently, but there are also C bindings being built. So that would make a completely different kind of level of integrations possible with the C bindings. So you can, you can check these on GitHub. And we also have an amazing new documentation website, so you can check that as well. I'm going to skip these because I think Alvaro is going to cover some of the JavaScript stuff in the workshop. Yeah, I don't want to go too much into the detail, but the main part of the Waku message, the message that you are sending, is the payload, which is your own payload, your defined payload. What do you want to send to all the other nodes, let's say? And then the content topic, which is like to define who cares, right? Like my application has this name. I send it to the content topic. Nobody else cares, so nobody else will read the messages potentially. They can, but it's not useful. So yeah, those are two concepts that I think, again, Alvaro will talk more about in the hands-on part of the workshop. I'll very briefly just say something about topics, because there are two types of topics in the Waku network. Pub subtopics, that's like the underlying lib peer-to-peer layer, we use lib peer-to-peer from like a Go lib peer-to-peer, lib peer-to-peer implementation. And there is a gossip sub protocol to distribute messages. So the pub subtopic is for routing to get your message through the network, and then the content topics are for content-based filtering. So to know what messages you actually care about in your application. I mentioned the DOS protection. So the way we do it is called RLN, rate limiting nullifiers. It's a very interesting technology, very complex technology. It's based on ZK proofs and membership sets. Very interesting stuff. I hope that you will learn more about it at some point. But basically, it is just a way to limit how many messages per second can people send based on whether or not they are part of some membership set. And there is also RLNV2 in the works, which makes it, which creates more fancy and capable solution. But we are integrating this into the public Waku network to make sure that the bandwidth is kind of controllable or capped for people to run the nodes. There is a bunch of Waku protocols. You can see them on the rfc.wac.dev. So I'll just talk about very briefly about the basic ones, so that I, again, leave it to Alvaro to maybe tell you more. But the most important kind of protocol is relay, which allows you to get the message through the network, basically gossiping messages through the network from a node to node. And it's kind of the backbone of the network. Without relay, we have no network, right? We could also say that there are discovery protocols, and without discovery, we have no network. So those are kind of two basic levels. But if we care about getting messages from A to B, then relay is kind of the main thing here. There are the light protocols. There are more like a client server, so you need to know who are you asking, whether that peer understands what you are asking it to do. It has to be kind of enabled there. And it's aimed at those browsers and mobile phones that do not necessarily need to participate in relaying the messages, because if you need to relay everything, then it's going to cost you a lot. It's going to burn your phones again. Back to that topic. So these allow you to publish message without being a relayer and get message in a very limited set, because you can filter the messages out that you don't care about. And that's very useful, again, for those adaptive nodes, which are maybe not online all the time, but mainly they do not want to consume that much bandwidth. Speaking about not being online all the time, the store protocol enables devices to ask a node, give me all the messages since this time when I went offline. And again, that's very useful if your device is not always online, living somewhere in the data center or on a very reliable internet. But then even if you live on reliable internet, there will be issues. So this basically, if you enable this protocol in your node operator, in your node as an operator, will store all the messages that go through your node. And then if anyone needs, they can query that. These protocols, basically, when we had the incentivization work in progress on the slide, these protocols kind of make most sense to incentivize, because they are kind of extra on top of relay, allowing for relatively straightforward way to incentivize people to enable those as something extra on top of the decentralized network. Waku also defines RFCs and implements them for encryption. So if you need encrypted communication between two or multiple peers, there is a relatively straightforward way to do it. You just need to use the right protocol and send the right messages, and you should be fine. And you can then have encrypted messages between your peers. I'm going to skip the examples because we want to save those for the hands-on workshop, I think. Yeah, and we are at the use cases part. So why would you use this, right? Like, maybe you know, but I didn't know when I first looked at Waku, like, oh yeah, chat. Yeah, I can send chat messages. That's awesome, right? But that's just a very small part of what you can do with Waku and with decentralized messaging in general. We care about decentralization, so we have decentralized applications, dApps, right? And those may need to communicate. They may need to communicate between each other, but also maybe you just need to send a message to your wallet application to request a signature of some message or of some transaction, right? So you can easily do it through this network. And even if we decide to not run the network, someone else may. So you can still use the same approach. Think something like Wallets Connect, right? You can think about marketplaces. A lot of what happens on the marketplace needs consensus, so you need to do it on blockchain. But then there is a layer on top, which usually these days will be centralized. It will be some API or it will be some database somewhere. But you could, a lot of it, do in a decentralized manner and use the messaging for that. Something like, someone liked your NFT, or someone wants to start an exchange with you. Would you like to continue with that? And things like that, right? And you can think of NFT marketplaces, but also generalized marketplace for anything. We have seen at ECC, we have seen a bunch of projects promising a decentralized cloud, right? So you can trade compute using that. And state channels, which is basically like off-chain computation of chain state in a smart contract, let's say. So if you need to synchronize between people participating in this off-chain computation or this off-chain action, you can use Waku or any other decentralized messaging, but Waku is the best, obviously. Game mechanics, I'm really always excited about this, although I'm not gamer and I am not a game developer, but I really like the idea that if I would be ever building a game, I could just, to synchronize state of all the players connected, I could just send a message to a network and then they would just magically synchronize. It's just so beautiful idea. So I think there is a big space for gaming to use this. Layer 2 coordination, so if you have validator, you need to coordinate. Signature exchange for multi-sig wallets. This is actually being kind of done with Gnosis Safe. There was a bounty for that, and it's been implemented. So normally with multi-sig, you would have to send, each signer would have to send a transaction on chain to verify that they are approving the transaction. But you could also do the synchronization of the signatures off chain, and then the last one, or some gas station network, would send the final signature, the kind of combination of the signatures, or the final transaction on chain. And it has been done as a bounty to use Waku network for synchronizing these multiple signatures for Gnosis Safe. So I think that's a really cool use case. And yes, then the last but not least, chat messages, exchanging chat messages, which Status Communities is doing. And I definitely recommend following Status on Twitter. They are posting so much, and it's super exciting, and I'm always hyped up about what they are posting about. I can't wait for it to actually come to life. So who uses Waku? So we have covered Status as an original kind of developers and proponents of Waku, and then also still using Waku and building on top of it. Then Railgun, which is like a privacy-preserving DeFi-focused protocol, I think. I think this is how I could explain it. I read it, what it is. I never used it, so I am very wary of not being to explain it properly. Then XMTP. XMTP is using Waku under the hood, and you may have heard that they have been integrated in Coinbase Wallet, so you could say that Coinbase Wallet is now using Waku under the hood, which is amazing. And then the graph is using it to synchronize some state of the validators, some state of the indexers, maybe some error synchronization based on what I understood. So yeah, those are kind of the 4 biggest projects that are using Waku, and there is way more that is being experimented on, that is being tried on, that is being kind of proving whether it will work or not. I'm going to skip this because we have the whole talent acquisition team, so if you are interested, then just find Angel or Maya or anyone, and we will direct you in a decentralized way. We will route you to them. We are looking for all the kinds of people. And then you can join our community even though if you do not want to join Waku team. It's okay. We like external contributions. We like them a lot. So if you have a question or if you just want to explore, we do have a Twitter, which there has not been much activity up until recently, but there is a lot of activity now. So it is a good place to be at. We have a Discord that has been recently split out of VAC Discord. So we have our own Discord. There is a support channel if you get into issues. We are happy to help you. But there is also all the announcement and all the different stuff. We have a Telegram, which I had no idea about up until yesterday. So if you know, tell me what is happening there. And yeah, we have a GitHub, which is a great place to start if you don't want to talk to us, but you do want to use Waku. And I'm going to move away from the QR code if anyone needs that. Okay, I am 5 minutes early, which I think is fine. But yeah, I think we can have some questions now and then some questions after the hands-on part if there are any questions. Because the hands-on part may answer some of those questions or trigger some more questions, which would be even better, I think. Yes?
Hello, that was great. If I run a node and my government is interested in what is passing through that node, do I have to worry about that at all? Is there any way, is there? If I'm running a node, what parts of the message come through that either can be detected that came through me or anything like that? Do I have to have any concerns about those sorts of requests from governments or other entities if I'm doing a node operation?
That's a good question. By default, I would say that everything is unencrypted and public. So if the government wants to see what's coming through your node, they could just start their own node and they would see what's coming through the network, all the messages, right? It's a public, open network. So this is more about how the applications built on top of it will deal with that, how they will include encryption, how they will include other methods of kind of not being able to read the messages. But it's privacy-preserving network, so there is no, if everything is done right, there is not really a way to see who sent the message. And then if you are just relaying the message, I'm not a legal person, so I can't say whether that would have any implication on what your government wants from you or not. So it's a public network, so if everything is open and public and unencrypted, then your government doesn't have to go to you, they can just join the network and read all the messages, right? I don't know, I don't have a specific answer to like, if they come to you, yeah, you can probably just you can enable store protocol, store all the messages and give them access to the database. Yeah, and it's up to the applications to figure out how to encrypt, how to prevent anyone reading users' messages, right?
I have another question, unless other people did.
Well, you can have a question and then other people can have a question.
On the storage piece that you were talking about of recent messages, does that integrate with Swarm or will it, or are those two sort of, is Swarm more permanent and versus ephemeral?
So, okay, so there are two kinds of messages in the network, ephemeral and non-ephemeral. Ephemeral messages will never be stored anywhere. And non-ephemeral messages will be stored in the store protocol, which is very simple right now. It's nothing fancy. It's just right now, from like 2 releases back, we have a Postgres. Before that, we just had SQLite. Now we have Postgres, so it's more durable. But it's not, at this point, it's nothing that like would be automatically offloaded to some very permanent, very persistent storage. And it's not the goal of it. It's, the goal is that if you have a node that may go offline and need to read the messages again, or you need to get the messages, there is a way to preserve some level of history of the messages. It's not a way to completely cache the history of all the people messaging, sending, or all the applications sending messages. So we will definitely like work on what's next, but I don't think that there is anywhere a plan for it to become an actual like storage for the applications, because that would be obsoleting some of other projects that are doing that way better than we could. We may be, or the community may be able to integrate some of the persistent storage solutions and leverage this to like actually persist the messages, but there is no specific plan about making it more permanent than just a cache of n days of all the messages that the node has seen, and then cleaning up, garbage collecting those messages that are older. Any other questions, anyone? We have 1 minute, so there's probably one question left. Yes, thank you. Appreciate it. Oh, yeah.
Great presentation, thanks. Since you are stating the privacy a lot, have you considered like doing encryption by default instead of node?
I don't know. Hanno, have we considered encryption by default?
No, so the routing relies on a common routing layer, but there's no linkability within the routing layer to any kind of origin of a message or the destination of the message. And on top of this, applications can build, and they can provide their own encryption methods. We do define some helper features for applications, such as conversational security methods, noise key exchange, various encryption mechanisms that they can use. But this is a layer above Waku. Waku really is just a routing layer that looks at these features of privacy and security, unlinkability, metadata protection in the network.
I think, and it was my perception as well in the past, that encryption allows for privacy. But then if you think about what privacy means, it's not about that. It's not often about that someone cannot read your messages, but they cannot be traced back to you. And that's what Waku does and what Waku aims for. And the encryption part is more of a like cherry on top that that nobody will be able to read your messages. But the most important part for Waku is that nobody will be able to trace your messages back to you. I think. Okay, thank you very much. I'm gonna hand over to Alvaro, which is also a Waku core contributor, and he will guide you through the hands-on workshop. It's gonna be amazing, even better than this.